So it's an SAT prep math, and again, it's the symbols category, but we're kind of going to make something up. We've seen functions before. We're going to do a double input function. So the reason I called it a double input function is because normally when we talk about a function notation, it's f at x, and the only variable in here is an x with a bunch of constants or coefficients. The problem here is we have an r and an s. So a function doesn't, the original function notation doesn't quite work for that. But you said you've taken data, and in data sometimes they represent a combination or permutation with like an n and an r like this. And this would be two inputs. You could call this like a double input function. So that's the kind of notation we'll use in this one. We'll say f at, we can say x and r, or we can say r and s, since these are r and s is what we're using. So instead of saying that heart, we have f at rs is equal to r times r minus s. Okay, so now we can kind of try to rewrite the function. The problem again is this is going to become a complex function to write because it's a heart within a heart. We have a function within a function. So let's kind of try to denote what the r and the s is in the bigger one here. We clearly have a r and an s here, but this too is also an r, and then all of this is technically an s also. Okay, so when we go to write it, the style I've used here, this f, we'll write it just in red. So we're only going to focus on the red one to start. So that's the overarching function at the moment. We have 2 of, and then we kind of have a smaller function within itself. You could kind of call that, I guess, you know what, I'll make it much larger so it's a little easier to read. We're kind of going to write almost 3 numbers in here. We're going to say the function is 2 at, and then kind of write that in brackets, 6, 8. So what we have is a function we have to deal with first, and then when we get whatever this is equal to, we now have a larger function. So we're going to start with, I'll write that one in green here, 6, 8. So let's start with the function of 6, 8 as a single input. So let's adjust this part here. Let's do that to start. Since we know that this is what that is equal to, our r is the first cell, so it's 6 times 6 minus 8. So we're going to evaluate each of them independently. 6 minus 8 gives us -2. So -2 times 6 is -12. Great. This is now the value we can replace this with. So now our red function here, f at 2, -12, is very, very different. So now we have 2 times 2 subtract -12. Again, remember that's the r times r minus whatever our s was, okay? And again, we're going to evaluate. So this becomes 2 times, this is like adding actually. So I could say 2 plus 12, so it becomes technically 14, and 2 times 14 is 28. So in the end, this entire thing here is equal to the value of 28 in this case, okay? So this one's a little tougher because it's a function in a function. So the notation is even hard to write, and the notation isn't important for this question. It just was to help us get a hold of what we were trying to do here.
I wonder if 28 is an option.